Let's talk about force. It's a word you've probably heard a lot, but what does it really mean? Force is all around us, shaping everything we do, even if we don't always notice it. Every day you push, pull, lift, and move things, using force, even if you don't realize it. From the moment you wake up and pull your blanket off, to opening a door or tossing a ball, you're using force in countless ways. In science, force is simply a push or a pull on an object. It doesn't matter if the object is big or small. Forces act on everything. Kicking a soccer ball? That's a push. The harder you kick, the farther it goes, all because of the force you use. Opening a fridge? That's a pull. You're using your muscles to create a force that moves the door toward you. Forces make things move, stop, or change direction. When you hit a ball and it bounces away, or when a car brakes to a stop, that's force in action. Without them, nothing would ever happen. Objects would just stay still, never moving or changing. When you push a friend on a swing or lift your backpack, you're applying force. Even the smallest actions like pressing a key on your keyboard involve force. Even standing still, gravity is pulling you down. Gravity is a force that keeps your feet on the ground and makes apples fall from trees. Forces are everywhere, all the time, like invisible hands making things happen. The wind blowing leaves or clouds drifting by are all caused by forces at work. To move, stop, or change how something moves, you need a force. Nothing changes without a force acting on it. Forces come from interactions, when two objects affect each other. Whether it's a tug of war or just picking up a pencil, it's all about interaction. You can't have a force with just one object. There must be at least two. One object pushes or pulls, and the other responds. For example, pressing a button, your finger and the button interact, creating a force. The button moves because of the force from your finger. This idea of interaction helps us see where a force comes from and what it acts on. It's the connection between objects that makes things happen. So, remember, a force is a push or pull that happens when objects interact. It's a simple idea, but it explains so much about the world. It's why books fall, cars drive, and birds fly. Every movement you see is the result of forces at work. Understanding force is the first step to understanding how the world works. It's the foundation of all motion and change. It's the key to unlocking the secrets of motion, from planets to atoms. Whether you're looking at the stars or the tiniest particles, force is always there, ready to explore what forces can do. Let's dive in and discover the amazing ways force shapes our universe. Forces are like superheroes. They can start, stop, speed up, slow down, or change the direction of objects. A soccer ball stays still until you kick it. A force makes it move. A rolling skateboard stops when it hits a wall. The wall's force brings it to a halt. Push a friend on a swing, and another push makes it go higher. Pull back, and it slows down. Forces can also change an object's shape, like squeezing a sponge or kneading dough. A baseball bat hitting a ball changes its direction with a powerful force. From starting and stopping to changing speed, direction, or shape, forces are the ultimate agents of change. Every time you ride a bike, play a sport, or open a door, you're using these powers. Forces shape everything we do every single day. That's why understanding them is so important. Some forces need objects to touch. These are called contact forces. They only work when two things are physically in contact with each other, making them a part of our everyday experiences. Muscular force is the power you use to lift, push, or pull things, your muscles at work. Every time you pick up your school bag, open a door, or even squeeze a lemon, you're using muscular force. Animals use muscular force too, like a horse pulling a cart or oxen plowing a field. This force is essential for both humans and animals to perform tasks that require movement or strength. Another key contact force is friction. Friction is the resistance you feel when two surfaces rub against each other. Friction opposes motion between two surfaces in contact. It's what stops things from sliding. Without friction, objects would keep moving without slowing down. Without friction, you couldn't walk. Your feet would slip like on ice. That's why walking on a frozen pond or icy sidewalk is so tricky. There's not enough friction to keep you steady. Friction helps brakes stop your bike, making it safe to ride and slow down when needed. It also lets you grip a pen or pencil, so you can write, draw, or create with control. But friction can also wear out machine parts over time, causing them to break down or need repairs. It can make it hard to push heavy objects, especially if the surfaces are rough or not well oiled. That's why we use oil in engines and machines, to reduce friction and keep things running smoothly, preventing damage and saving energy. So, contact forces need a direct touch. Muscular force lets us move things, and friction helps us control motion. These forces are always at play when we interact with the world around us. Friction is also why rubbing your hands together warms them up. The heat you feel is energy created by friction between your palms. Understanding contact forces helps us see the mechanics behind everyday actions, from playing sports to using tools, or even just walking across the room. They're the hands-on forces shaping our world, allowing us to build, create, and explore. Next time you walk, write, or ride a bike, remember, contact forces are at work, making these actions possible and safe. They make daily life possible, connecting us to the physical world in every moment. Not all forces need contact. Some act at a distance. These are non-contact forces. Magnetic force is a great example. Magnets attract or repel without touching. It's what makes fridge magnets stick and powers electric motors and maglev trains. Magnetic force is strongest at the poles. Opposites attract, likes repel. Gravity is another non-contact force. It pulls everything toward Earth. Gravity keeps us on the ground, the moon orbiting Earth, and planets circling the sun. Even though you can't see or touch them, magnetic and gravitational forces shape our universe. They show us that objects can influence each other without contact. The world is full of invisible forces working behind the scenes. Now, let's talk about pressure, a close cousin of force. Pressure is the amount of force applied over a certain area. The formula is simple. Pressure, mass, force, area. Walking on snow in regular shoes? You sink because your weight is concentrated on a small area. Wear snowshoes and you don't sink. Your weight spreads over a larger area, reducing pressure. A sharp knife cuts easily because its thin edge creates high pressure with little force. A dull knife needs more force for the same effect. Nails have pointy tips to concentrate force and drive into wood. Wide backpack straps spread weight, making them more comfortable. Pressure explains why sharp things cut, snowshoes work, and wide straps don't hurt. It's a key principle in science and everyday life. Remember, it's not just how hard you push, but how much area you push on. Solids exert pressure by pressing down on surfaces due to their weight. This pressure is a result of the force of gravity acting on the solid object, pushing it downward onto whatever it rests upon. Every solid object, no matter how big or small, creates some amount of pressure on the surface beneath it. The pressure depends on two main factors: the object's weight and the area it touches. Heavier objects press down with more force, while objects with a larger contact area spread that force out, reducing the pressure on any one spot. For example, a heavy book lying flat on a table spreads its weight over a large area, so the pressure is less. But if you stand the same book on its narrow edge or corner, all that weight is focused on a much smaller area, increasing the pressure dramatically. That's why buildings have wide foundations, to spread weight and reduce pressure on the ground. If the foundation were too narrow, the pressure would be so high that the building might sink or damage the soil beneath it. Lying on a bed of nails is safe because your weight spreads over many nails, lowering the pressure on each nail so none can puncture your skin. The more nails there are, the less pressure each one feels. But if you step on just one nail, all your weight is concentrated on a tiny area. Ouch! The pressure is so high that it can easily pierce the skin. Camels have wide, padded feet to walk on soft sand without sinking, just like how snowshoes help people walk on snow. Both spread out the weight, keeping pressure low and preventing them from sinking. Tractor tires are made extra wide for the same reason, to avoid sinking into soft soil by spreading the heavy machine's weight over a bigger area. By spreading force over a larger area, we reduce pressure and prevent damage or discomfort. This idea is used in many tools and everyday objects to make them safer and more effective. This principle helps us design safer buildings, better tools, and even explains how animals have evolved special features to survive in their environments. It's all about balancing force and area. Understanding how solids exert pressure helps us solve real-world problems, from construction to nature. Liquids and gases, fluids, exert pressure too, but in all directions. In a balloon, water or air pushes out on every part of the surface. Dive deep in a pool, and you feel more pressure on your ears. The deeper you go, the greater the pressure. Pressure in a liquid increases with depth, and is the same at any given level. That's why dam walls are thicker at the bottom. Gases like air also create pressure. Pump up a tire, and air particles push on the walls, making it firm. The more air you add, the higher the pressure. Fluid pressure is key for hydraulic machines, breathing, and even weather. Remember, fluids push everywhere, not just down. Understanding this helps explain everything from swimming to flying. Pressure and fluids is all around us, every day. We live at the bottom of an ocean of air, the atmosphere. This air has weight pressing down on us as atmospheric pressure. It's huge, but we don't feel crushed because our bodies push back with equal pressure. Drinking with a straw? You lower the pressure inside, and atmospheric pressure pushes the drink up. A rubber sucker sticks to a wall because outside air pressure is greater than inside. Atmospheric pressure drops as you go higher. On mountains, there's less air above you. That's why mountaineers need oxygen tanks. Atmospheric pressure affects weather, flying, and even cooking. It's an invisible force shaping our world. Force and pressure are everywhere. From walking and playing sports to breathing and building skyscrapers, opening a door, cutting an apple, or riding a bike, all use these principles. Science isn't just in labs, it's in your kitchen, backyard, and body. Remember, force starts, stops, or changes motion. Pressure depends on force and area. Connect these ideas to real-life examples to understand and remember them. For exams, know the effects of force, types of forces, and the pressure formula. Science is about asking questions and discovering how things work. By mastering force and pressure, you unlock the rules of the universe. Keep exploring, stay curious, and see the world with new eyes. Science rules.